At this time, let's begin today's Hexagon Geospatial Snapshot webcast, Different Solutions for Processing Drone Imagery. It is my pleasure to introduce your speaker, Joe Mustawi, Senior Applications Engineer. With that, I will hand the floor over to you, Joe.
Great, thanks Jessica, and just to segue into what Jessica was saying, this presentation will be more of demonstration rather than presentation. I like to keep it live and interactive, and so hopefully everyone can hear me fine. If not, my colleagues will help me out with a little bit of sound bites or questions. I do have a separate monitor that I can kind of see and kind of keep an eye on at the corner of my eye. Anyway, let's move on. We're going to be talking today about different solutions for processing drone imagery. So I'm hopefully going to hit on, let me just move this slide on here. This is the only slide I'm really going to talk about, and just kind of to go through what I'm going to be showing today. So we're going to be looking at the user interface, the GUI version of Imagine UAV, and how that is used, and kind of why you would use the GUI, the graphical user interface, as opposed to the other options listed underneath that, which is the spatial modeling option, which allows you to, instead of processing with using the GUI and just some loading in some files, we can actually edit some models and run it from the modeler. And then we're going to go into kind of some photogrammetry applications, so taking that model and why the benefit of the model applies, and then also extending that into a photogrammetry area, which actually I might follow up in the end with, just so that I can hit on the GeoApp.UAS, which is our cloud-based offering, just before the photogrammetry, so that I have enough time. There's a lot of things to show in the photogrammetry window that I could spend a lot of time on, but I have a feeling I'm going to run out of time if I do that. So that's the overall goal for this morning. Let me just share my screen, and let's get started with the demo. Let me just get rid of that little thing here. So what you're seeing here is our Imagine interface. So Imagine has been around for 35 years, give or take, and so it's a platform that does remote sensing, photogrammetry, and GIS applications, and now extended into the UAV platform, which UAV images, as you know, are a little bit trickier to work with their small footprint and kind of less stable platform of collection, making the math a little bit looser. And for our tighter photogrammetry packages, they're more high-end engineering grade. They require more of a tight solution, tighter GPS, IMU, that kind of thing. So just to cut into it, let's get started with the Imagine UAV is an add-on. When you run the executable, it installs this tab that you see here. I think I might have added maybe the terrain prep tool onto here, but pretty much what you see is part of it. And then when I click on the Run UAV Process, it will fire up this GUI here once I get rid of this that window. So to start off with, in this selection, why would I use the Imagine UAV GUI interface? Well, it's straightforward, easy to use, anyone can populate it, and typically the default settings, with the exception of maybe projection and output file names, are usually pretty good. So what I mean by that is I would just come in here and specify my images folder, type of image support that I have. The standard format for most UAVs these days is JPEG with an embedded EXIF file, EXIF data, I should say, which is your GPS IMU data if it has it. And if not, you can use an external orientation file, an outside file. I have a bunch of these already set up for different clients and that kind of thing, but very easy to set up. If you go into the edit orientation formats, it basically says, hey, how do I read this file? Where's my X, Y, and Z, omega phi kappa values? What rows and columns are they in? And do I have to skip a bunch of garbage at the top of my file? If so, just set that up so that it reads that properly. Very easy to do. But assuming a JPEG file, if you don't have JPEGs, you have some kind of crazy format, that's where Imagine nicely comes into play, where we read thousands or at least hundreds of different formats. We've kept up with our format support over the decades, so obviously we support anything you're going to throw at us, even if it means just dragging and dropping it into a viewer so that you can see if it's supported. Most of our DLLs support that. Moving on, so assuming a JPEG with an EXIF data, that will provide me with my orientation information about the center of each image. And then I would just simply specify a low accuracy if I want to run a quick preview, or I could have just left the default. Like I said, the defaults usually work. And in this case, I know my projection is in geographic lat long, which is EPSG code 4326. You could specify a UTM EPSG zone or escape plan, whatever you want, as long as you have that information in the EXIF data. And then finally, like I said, you're just basically specifying where you want your outputs to go. So maybe this is which one's first here? The last file. So I would come in here and just say TTT, just to keep it quick. Again, come in here. This is my mosaic. So I'll call this one JJJ, and so forth. So I'm not necessarily going to run this. Actually, this little data set here I have, I think there's only about 15, 20 images, would only take about 4 or 5 minutes to run tops. And I could run that. I'm not really concerned with you seeing that. I'm sure you sometimes, maybe I'll run the GeoApp one, but just at the end. But you know, to me, the time is irrelevant because they all take about the same time. Between any of the standalone UAV processing engines out there, they take about the same time to run as does our Imagine UAV, our GeoApp.UAS, our Imagine Photogrammetry Suite. All of them, really, they take all about the same time. So to me, that's all apples to apples. The one really nice benefit here is the batching capability. So as much as this particular project may be quick to run, when you have 3, 4, 10 back-to-back projects that you wish to run, the simultaneous processing of all those projects at the same time is invaluable. That will save you a lot of time and obviously ROI. In addition to, we do have distributed processing available with our Condor installation, which is a free software which allows you to distribute these processes across multiple machines. So multi-node processing, multi-machine processing with multiple processes of processing, which really speeds up. So 3 different ways of not all the same, you can do all the same all at once. Anyway, enough of that. So that's the GUI. That's the quick and easy way to produce LAS, DSM, and mosaic files. Okay, there's not a lot of interaction, which is fine. For those that just want a mosaic, maybe like you see here, or a point cloud like you see over here on the top right, maybe that GUI interface is good enough. Or maybe one of those standalone applications that are out there is good enough. You are missing, with the external standalone options, though, you are missing, again, all that format support, knowing you can trust on vectors being draped over top with no problem, any shapefile, Mr. SID, ECW, compression, you name it, JP2, anything, any file format out there we support as the file type that you're using, or maybe even as a backdrop. That should be considered so that you don't have to keep coming and going to and from softwares in order to get your job done. All right, enough of that. So now what we would do is, another one of these options is view the model. So I can actually view this spatial model that the GUI was running in the background. So this is the, let me just kind of zoom into here. I know I'm kind of tight on real estate here, but I just want you to kind of see everything all at once. So what you see here in these 3 operators is actually what is running in the background on that GUI that we've already seen. Okay, so to populate that GUI would be the same thing as populating this model. The first advantage of this model is that if I'm running the same directory of folders or the same process, I don't have to upload that GUI. I can just specify this directory of where these images are, say OK, and then save this model, and it knows to always go to that directory of folders, of images, I should say, a folder full of images. So now if I save this model, open this model back up, hit the Run button, I don't have to worry about the GUI, the interface. I can just run it from here, and all my parameters are set. I might always do a low orientation as opposed to high because I like a quick result to see where I am. And so again, save this model, load it up, run it, good to go. Okay, so we're already seeing a benefit of this, especially if you're doing the same kind of pass over and over again. You're using the same, say, folder of imagery or of the same area, that kind of thing. And that's just one advantage of the modeling environment. The second advantage of the modeling environment is, first of all, most of these software pieces that will do UAV processing will produce a mosaic, LAS, and DSM file. For the most part, you're going to get similar, if not identical, results with the triangulation process, especially if they're using the semi-global matching algorithm as an intermediate, which all of our UAV processing engines are, and then tinning and then producing output results. But if they're not using semi-global matching as the underlying elevation source, your results actually may suffer. Semi-global matching is a very powerful and extremely good hard edge result, a DTM or surface model extraction engine. It's a point cloud that will produce edges of buildings and chimneys and that kind of thing very, very nicely. So therefore, the accuracy of your orthomosaic will be very accurate as well. Okay, let's get rid of that. I don't want to save my changes. Moving on, the reason why I like the modeling environment for this, in addition, is because first I run my typical UAV processing engine, but then the next step is producing an output, producing not only a LAS output or a mosaic output, or maybe I could care less about mosaic. All I care about is the point cloud. And in this case, maybe all I care about is actually extracting the volume from that output. Now I'm at a value-added stage where I'm not just producing a LAS file, I'm producing a solution. That should be hit home right there. That key term solution is very important to me at least. This is what I strive to get my clients to understand or get them to get. I can get them very easily a mosaic, a DSM, and point cloud. Getting the solution is a little trickier. Having that solution saved as a GMD, a spatial model, so that they can use it again and again, means I don't have to build it once, pass it off to my intern and say, hey, run this on these images and give me a result, and I want to see the volume of this, this stockpile or this stockpile here. And they can very easily do that by showing and running that model. Okay, so we've gone from the GUI interface, which is basically point to a folder of images, give me produce me some mosaics, some LAS files, and some DSMs. Second option is using Imagine UAV in the spatial model, where Geosystems, our partner over in Germany there, has put together this Imagine UAV operator definition and runs the GUI, and behind the scenes runs these operators and puts it all together so that we have these capabilities within the spatial modeling environment. So the second option, Imagine UAV from the spatial modeling environment, allows for solutions. Now we're getting to the solutions level. And if I pull up another one of my solutions here, this one is a little bit more advanced. Nothing too crazy, but I think if we kind of zoom in on here, this is the processing engine that runs the triangulation, computing my surface. And as you can see, I can produce a DEM, a mosaic. In this case, I might want to produce a LAS file. Again, maybe producing a solution. In this case, my solution is I want to classify that LAS file. And then as I classify that LAS file, I'm producing an output. My next step might even be to separate, low vegetation or medium vegetation from that, which as a class is now just a set of points that I can then rasterize, I can vectorize that, or I can use them as is, get a volume off that. I hope you can see where I'm going with this. Additionally, I can also produce a block file. Again, Geosystems set us up with this operator to produce a block file, which is very powerful because what I can do then is bring it into Imagine Photogrammetry, which you see here in the bottom middle. I just have a block loaded up. I actually have this project file loaded up. What you're looking at here, top right, is a point cloud. Top left is a clip to convex hull of the area of the imagery, a mosaic, if you will, with contours draped, all derived from this process. And down below, getting back to the photogrammetry project, You can see here I have a bunch of images. I have, let me just clean this up a little bit so you can kind of see. Let me turn the terrains off. Very easy to see the footprints of each of these images, and you can see the points that were collected. I can collect control points now, and I will go into that a little bit more after I do my GeoApp.UAS. But it is nice to see that I can, move between any of these images, and it shows the power of exporting to a project file, because I'm now given all of these project file operators that I can work with. I can create SGM. I can use my older, surface model extraction engines that maybe aren't quite as tight as the SGM output is. I can go into terrain editing in a stereo mode, edit in terrain. I can go into stereo analysis for Imagine. I can also alternatively output single orthos, or obviously orthomosaics, which you typically get from these standalone UAV processing softwares, as well as our own Imagine UAV product. And keep in mind that we use the code from Agisoft PhotoScan in the background here. So it's not something that we just put together and said hopefully it works. Agisoft PhotoScan, as you know, is tried and true and tested in the industry. It's one of the top UAV processing engines out there, so very reliable. We're just taking that triangulation code and saying, okay, give me the initial triangulation, so I've got a nice tight solution, and then let's do something with it. Let's create some solutions. Let's create projects so I can go in and collect control in a stereo environment, or run my own SGM from my project, or run orthos as opposed to an orthomosaic, or DSMs, or view in stereo for feature collection if I want to collect my bridges and my hard edge, anything, any kind of the sides of the roads you want to be more accurate with rail ties getting in the way, or the rails themselves. Okay, so I'll come back to that. That's the photogrammetry software that you know. I want to step into really quick on the cloud processing option. Why would you use the cloud processing option? You'd use the cloud processing option because maybe you have the ability to upload your files when you're out in the field. You could be, maybe right from your tractor or something. You could load it right from there. Or you have imagery that you don't have as robust a system as, say, I do. I'm actually working off a laptop, so this is actually not a very powerful machine, but it just goes to show you don't need much to run it. But when you're crunching, a lot of images, you want, obviously the most powerful machine to do that, right? So here's just our map chest utility. That's basically a storage mechanism for any kind of file type, be it images or documents or PowerPoint, whatever. We have this map chest environment, which is a very slick and powerful utility that is also shared across networks if you want to be. I have a lot of these data sets. If I were to back up here just a sec, a lot of these data sets aren't even mine. They're some of my colleagues' data sets, but I also have mine that I've shared with them, so if they want to use my data, it's very easy to do so. And so this is a storage mechanism. It's very easy to find out information about images, or maybe this one's already compressed, but I would have the ability to compress and use ECW compression right here, or if I have point cloud blast files, I can do HPC compression, Hexagon point cloud compression. So very powerful mechanism for storing a lot of these big images, but compressing them down so they don't take a lot of storage space, which could save you tons of time and money in and of itself, because if you have all your image files compressed and all your last files compressed, obviously it's going to take up less space, and ergo less money is usually the end result. So I just have a few apps that I have on my marketplace. So this is our smart map environment. I'm going to show you the GeoApp.UAS, which is our cloud-based processing for UAV imagery. And when I click on this, it'll pop up the little interface. I can go to my previously defined jobs outputs. I'm going to walk through a typical setup just to show you how really easy it is, and then hopefully we'll finish off here with a quick project demo on the photogrammetry side. But the reason I'm leaving that one to last is because I did a webcast probably 3 weeks ago, maybe a month ago, that actually steps you through triangulation of a project, exporting to a project so that it can be used in Imagine Photogrammetry, and then I show you how to import some GCP points, collect some control, and automatically find those control points on all those images, especially images that overlap like 20, like a point that overlaps 20 images. It's very time consuming. So I would select a folder in here, back to GeoApp.UAS. I got 6 images. I got a 7th one. I actually have a mosaic in there. That's fine. I'm going to say let's only select the JPEGs, though. That way, that 7th image, you might have seen this change from 7 to 6. It's only the JPEGs I'll be grabbing. Again, I described how the orientation formats work. If you have an external orientation format, you can load that in here. Otherwise, typically EXIF data is used. And then I would say I like to use low for preview, but we have other options. High for production, for higher quality accuracy is really the key there. But you can try it at low, try it at high. Obviously, the high takes a little longer to run. My open projection, GeoLat long. I'm going to go and find a place to put this output file. Let's just call it OD2, just so it doesn't interfere with anything else I have. I have a couple different formats I can choose from here, JPEG 2000 or HCW. I can also use as well. So that's for the mosaic. So in this case, I'm producing a mosaic, possibly a DSM. I'm actually going to turn that off, and possibly a LAS. I'm going to turn that off too. I would just obviously specify in my map chest where I would send those, and then but I'm going to turn those off just because sake of time. And then this gives you a summary of what's going to happen. I got 6 images at 4326 projection. I'm going to send to the output folder called iBotics Outs, and it's called OD2, blah, blah, blah. If you see anything wrong in here, it'll red flag you. It'll say you're missing a mosaic name or a DSM name, so please fill that in. And then you just simply hit the process window. And this will take, usually takes longer to validate and execute than it does to actually run it, but this set of, say, 15 images probably will take, I don't know, 4 or 5 minutes. Like I said, the processing time across all standalone Imagine UAVs, the GeoApp.UAS, all are about the same. They really are. You'd be hard pressed to really push the envelope of quickness and time of processing on any of these processes. And while I'm in here, I just wanted to show you that this is our webcast page. So if you go to support webcasts, you come to this Hexagon Geospatial webcast, and here is the other one that I did on March 24th, UAV import. So if you like what you see here and you want to know more about collecting control points in a stereo environment, loading in a set of GCPs and automatically finding those GCPs across an overlap of 20 images, as opposed to doing them one at a time, feel free to check that out. And you'll see this one show up here in a day or two as well. So that's the one we're on right now. So we'll come back to this. I'm actually almost out of time here, but I just wanted to kind of show really quickly the results that we're getting from here. So I created these contour layers even with just this terrain prep tool. I believe these actually I might have generated from the photogrammetry tool. If I go into my terrain editing environment, I can drape over top the the DTM or the TIN file that I have. TIN file allows me to collect break lines, and the break lines will obviously make changes to my DTM automatically, and I can discard or keep those changes. So here, if I just load up an image, and let's load up the TIN file, and I'm not going to take too much time on this, but I just wanted to kind of show you this is actually a great area to work in. And while we're on this, I'm going to let's just finish up there. I'm sorry I ran out of time to kind of show you this, but I actually do a pretty good job of showing the stereo viewing capability in the previous WebEx that I showed you the location of. So please check that out. And as you can see, my contours are coming up as we speak, and I can come in here and collect my own break lines. That's really all I wanted to show you. And just the ability to not only create those break lines, but to export those, right? So whatever changes you make to here, if I add a break line here, you'll see the contours are actually generated on the fly. These are just a rendition of what the points, the postings are doing. And right now I don't have I just need to change my settings so I can include more contours. That's very easily done. And of course, we obviously support tri-view, mono mode, anything you want to get in here and take a look at those contours a little better and do a more accurate measure. So with that, I'm sorry I have to cut this, stop it there so that we can be done in 30 minutes and get back to Dave. So Jessica, if you could pass me back to Dave, that would be great after I stop sharing my screen.
Great. Thank you very much, Joe. Appreciate that. It was a great demo showing the different options in processing drone imagery, both in our Imagine UAV add-on product, and now with the online capability, the GeoApp.UAS, one of our new smart map applications. So thank you very much, Joe. Let us move on. We do want to honor our 30-minute webcast footprint. So we'll put some polling questions up on the right-hand side. We always like to ask these and give people an opportunity to provide some feedback. We're always interested in hearing what topics you would like to see covered in future webcasts. We're constantly planning out what we're going to be talking about on these webcasts, and we'd like to hear your feedback. And of course, if you're interested in pricing for any of our products, you can select the product. And be sure you hit the submit button in the lower right-hand corner of the polling pane on the right-hand side to submit your answers. As Joe mentioned, our webcasts are published on our support page. I've got the address shown there on the screen. The webcasts going back through last year are all published. The one that Joe referenced is available in the list. You'll see it. And then here are our future webcasts that we have scheduled. So today is on drone imagery. Next week, April 28th, we're having a webcast focused on our university community, getting the most out of your Hexagon Geospatial University Education Bundle. So that should be of interest. And then we've got a couple scheduled for out in May dealing with publishing spatial models, and then another one on high-volume production with image station photogrammetry. So some good content coming on the near horizon. And then one word on our Smart Map initiative. If you haven't heard about this yet, this is our new platform initiative, online cloud geospatial platform for building and publishing geospatial applications. The GeoApp.UAS app that Joe presented is an example of that. That one is out on the exchange and available for people to run today, along with MapChess. That's the other one that Joe showed. We have got a marketing program called Ignite that's going on this year. This is a combination of workshops that are moving around different cities around the world to introduce people to the Smart Maps platform and show how easy it is to use the studio to build Smart Map applications. And part of that is a competition. We're looking for the best Smart Maps being developed from developers and users around the world. And we'll end up with over $250,000 in award money being given out at the end of the year, with the winner earning $100,000. So quite an opportunity for people, developers who are looking for a way to build some simple geospatial apps using our technology stack, and then publish those on our exchange for resale. So something to consider. I've got our contact points up on the screen. Justin Bird, our inside sales manager, and Joe Mostovi, our speaker today. And with that, we've got some questions that have come in. I appreciate that. Let's take one or two questions as our time permits here. Joe, we've got a good one here. Can this solution be utilized for images captured by simple UAS cameras like the UNEC, Y-E-N-E-E-C, UNEC Q500 4K camera? Can you address that one, please?
Absolutely, yeah. We are sensor agnostic and platform agnostic for that matter, but all we really care about is the images that are coming in. So the images can be from any source. That was the problem before, where the sensor models themselves were not tight enough to really dial in a UAV solution with a small footprint and a low flying height. But now the Agisoft code in the background there is it figures out the camera lens parameters and distortion parameters for any given camera kind of on the fly for you. You don't even have to enter those parameters. It's all automated, and therefore any camera, any sensor you use, you just throw it in there and it'll take care of that business for you. So
okay.
yes.
All right, thank you, Joe. Folks, we are out of time. We will come back. There are some other questions that were submitted, and we do appreciate those. We will come back to each of you and provide some answers to your questions. Listen, we thank you very much for taking the time today to listen to this webcast, and we look forward to having you at our future webcasts. Thank you, and have a great day.
And Dave, if you could just pass me over the ball while people are signing off, I'm just going to bring up my results from the GeoApp.UAS if it interests them to view them. All right, let me just get this out of the way. So here's my results. I am just going to see where it says show the results in the job in the map view. So it will drive to that location of the results. And in this case, all I created was a mosaic, but it is pulling the information from MapChest and sending it into the viewer here and publishing it, really. This usually doesn't take long. This is just a matter of regardless of the size of the image, it'll take about the same time to bring this up. But yeah, we're working with WebEx, and so this might take just a second here. And but again, thank you for your time, everyone, today. And we will be sure to check out my other webcast, quick and painless. It's very quick. It runs through a lot of stuff very quickly as well. And you may just got too much going on here. This should take about 12 seconds to come up. So, but in any case, it would show right here, and will in a moment as soon as I log off of WebEx. No doubt, I got too much going on in the background, but that's okay. Thank you for your time. Have a great day.
Thanks again, everybody. This does conclude our Hexagon Snapshot webcast, Different Solutions for Processing Drone Imagery. You are now free to disconnect. Thank you.